So, street tree inventories. They're used by municipalities to justify budgets and document actions, and also to foster community relations between municipal governments and residents that live there. Uh, Street tree inventories are principally a management tool for arborists and urban foresters that are employed by these governments and focus on planning and maintenance efforts, and then risk assessment and risk mitigation, and the quantification of ecosystem services of the trees that are within the municipality. Traditionally, street tree inventories require some basic information, like the species of the tree, the physical location of the tree, certain biometric parameters, and maybe the condition and health risk related to the tree. Um, Diameter at breast height is the most commonly used biometric measurement for trees. It measures the diameter of the stem at 1.4 meters above the ground. It can be used to determine many variables related to tree growth and forest management. Unfortunately, gathering street tree inventory data is costly in terms of time and resources. But with new advances in remote sensing technology, there are new ways to collect certain parameters for street trees to partially complete inventories between intervals, which are usually about 10 years or so for large cities. There are two principal ways of collecting 3D data: laser scanning with LiDAR, laser detection and ranging, and then photogrammetry, which uses taking photos in a series and combining these photos to make a 3D representation very similar to what you get with laser scanning. LiDAR systems are pretty expensive and can be used on mobile terrestrial rigs like a vehicle at the centimeter or below level accuracy. However, it's really costly to buy one of these units, $100,000 to $750,000, and $1,500 for rental a day. Photogrammetry, on the other hand, has been used to produce 3D maps to combine aerial imagery over many different positions. However, it hasn't been able to be used on this level on the ground with a vehicle until recently. And it's generally much cheaper in LiDAR, only costing a camera and a computer and a license. With a large amount of control points, we have been able to get the error to 10% for measuring DBH with this method, which is generally about the same as LiDAR. So from here, we're still conducting an experiment, but we intend to keep removing control points to ascertain the limits of what is needed to get accurate DBH measurements of street trees.